check the notes and you see that there is a table that I put into the notes for possible quantum numbers. So we're going to fill that in, and I'm going to explain why each one of them works. So for the first energy level, so like I said, we don't start with 0, we start with 1. So energy level 1 is going to be pretty much have your hydrogen and your helium. It's only got one, since there's only one quantum number here, it can only have one quantum number for L, which is going to be 0. Okay, that indicates that it's an s orbital, and that's it. So this also means 0 for here. There's only one quantum number that I can get for each one of these. And now for this, it's still going to be the same no matter what. 1/2, negative 1/2. So those are my acceptable quantum numbers. We then go to the next energy level. So you're going to see that as we go through the periodic table, and this will make a little bit more sense when we do electron configuration next week, but when you look at the periodic table, you'll see that neon has 10 electrons in it. It's got 8 from helium to neon. There's an 8 electron difference. So that is how many you can have in an s and a p orbital when you have those orbitals together. So you're going to still get an s orbital, and you're going to get a p orbital, which is 1, which we'll explain in a minute what that is. So s is always going to have 0. This is going to have negative 1, 0, positive 1. And then my my spin quantum numbers is going to be the same. Okay, so now we go to the third energy level. When you get to the third energy level, you will include the d orbital. Okay, we'll see when we do an electron configuration in a little next why that's kind of weird and could be a little bit confusing. Okay, so this is going to have 1, 2, so 0, 1, or 2. Now remember, 0 is always just going to be 0. This is going to have negative 1, 0, positive 1. And this will have negative 2, negative 1, 0, positive 1, positive 2. Okay, so these are just possible combinations. So what I could do is I could tell you, hey, n is equal to 2, L is equal to 0, M sub L is equal to 0, and my M sub S is positive 1/2. That's an acceptable set of quantum numbers. It means that it's in the second energy level in an s orbital within one, well, the s orbital doesn't really have any other directions, okay? So there's not a p sub, or there's not an s sub x or x sub y or anything like that. It's just s. So it's in the s direction, and then it's going to have a positive spin, okay? But if I looked at the p one, so let's say I said energy level 2, I chose my L to be my quantum number, so I do 1, negative 1, positive 1/2. Well, now that means that I'm in the second energy level in a p orbital. Believe this is p sub z 1/2. Okay? So that means that my electron's in the z direction of the p orbitals. So it's in the p orbital in the z direction. Okay? So this is the same no matter what. 1/2, 1/2, 1/2, 1/2, 1/2, and 1/2. So positive and negative 1/2 for each one of them. You're going to notice M sub S doesn't really change. And that's because you can only have 2 electrons within those orbitals. So that P sub Z is only going to have 2 electrons. That P sub Y is going to have 2 electrons. P sub X is going to have 2 electrons. Okay? So you can only have 2 different options. And then the fourth energy level is going to get 0, 1, 2, and 3, because we will now include our f orbital, which I'll never have you draw, and I will not draw myself. And that's going to give 0, negative 1, 0, positive 1, negative 2, negative 1, 0, positive 1, positive 2, and then negative 3, negative 2, negative 1, 0, positive 1, positive 2, positive 3. And the f sub s is just going to be the same thing we've been writing this whole time. Okay? So So these are my possible quantum numbers. So you will see questions on your quiz what an acceptable set of quantum numbers is. The first number is always going to be n. The second number will be L. The third number will be M sub L, and the fourth number will be M sub S. So, you look at your chart. You can have your chart out for you. I've got my pretty chart here. Okay? You can have your chart out, and it would tell you exactly where things are. Okay? So, what does this L portion mean? I've been talking about orbitals for a while, right? So, if I'm in energy level 1, and my L is 0, obviously, because that's my only option. I'm going to get an S orbital, okay? Which is going to be a sphere. That's my drawing of a sphere. Talk about my artistic abilities, okay? The next one. So I'm in energy level 2, right? Because 1 doesn't have an energy level of 1. It only has an energy level. L doesn't have an orbital of P. It only has an S orbital. Okay? So if I'm in energy level 2 and my L is 1, then I'm going to have a P orbital. Okay? And it looks something like this. My drawing skills are fantastic. Okay? So that's a P orbital. So that's got essentially a figure 8 in the X direction, a figure 8 in the Y direction, and a figure 8 in the Z direction. Okay? And I'm trying to draw things 3-dimensionally that are on a 2-dimensional, so bear with the paper and everything. And if you're not great, just as long as you know what it means, we're all good. Now remember that third energy level. So that second energy level, I couldn't get a D orbital, right? Because I can't have 2. My M sub L shall always be a little bit less than my N, okay? So, I get my energy, I get my 2. That's going to give me a D orbital, okay? And that essentially is going to look like this. Terrible drawing. But it's going to have 5 figure 8s, okay? And that's because it actually goes into the P sub XY and P sub YZ. And you don't need to worry about that and what that means for you. It's okay. Just know it's got 5, okay? The last one is 4. Remember, we got that 3. Now, remember I told you it's an F orbital. I'm never going to draw F because it's got 7 figure 8s. So I'm never going to be able to draw that. Incapable of drawing that. So, what is the S orbital? So, the S orbital is the first orbital that you're going to see within each energy level. Okay? So, its shape is similar to a sphere, and it only contains 2 electrons. And that kind of makes sense, right? Because if we draw our sphere, and then I write my X, Y, Z, it's going to be the same in all directions. So, I'm only going to, I can't have, figure 8 because it doesn't really do that. A sphere does not have its equal in all directions. So, this is going to be my, I think I did it, X, Z, Y. Doesn't really matter. The point being is that the shape of the sphere is going to prevent it from having more than 2 electrons. So, when we talk about electron configurations, our S orbital is going to be to the left side of the table. Okay? The next is then you get up to the second energy level and we get into P orbitals. So this is going to give you 3 figure eights. Put together. And it'll contain 6 electrons. So, if I draw my wonderful, again, I'm going to get 1 to go this way, 1 to go this way, and 1 to go this way. And you'll have to, hopefully, I drew it a lot better on the actual. So, this is going to be my, so if I make this my x, z, and y axis, this orbital is my p sub x, p sub z, and p sub y. So now that magnetic quantum number, the magnetic quantum number now makes sense, right? Because it's either saying it's in the positive y direction or the negative y direction, or the positive z direction or the negative z direction, or the positive x direction or the negative x direction. Everybody understand? So that's what this tells us. It tells us where it is within our period, where it is on here. Okay? The next one is going to be our d orbital. So this is going to contain all of our transition metal elements. So, d orbital. And that would make sense, right? Because 2 to 12 is about 10. And you'll see that it's got 5 figure eights put together. So it's going to have 10 electrons. So I'm not going to draw my wonderful lines for this one. I'm just going to draw 5 figure eights. Okay? My terrible attempt at drawing 5 figure eights. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay? 5 figure eights. So this contains 10 electrons. Okay? So it's the next step up. And that's why we get this P sub x, or D sub xy and D sub yz. Don't need to really be concerned with those numbers, but it just gives you an idea of how we apply those quantum numbers that you were looking at in the previous table that we did. And then the final orbital, and what will be the last thing that I want to discuss with you guys, because I had planned for you to do a lab during this time as well, so will be the f orbital. So, and this is going to be 7 figure eights put together and contains 14 electrons. Okay, so I'm never going to draw the f orbital because I'm incapable of doing that. I can barely draw a d orbital as it is. So the f orbitals has got 17, or 7 figure eights put together and 14 electrons. So that's the lanthanides and the actinides. Your ones that are separated from the periodic table, that's why they have 14 rows there. That's why that's the case, or 14 elements there. That is the reason why. They are going to have 14 electrons, and so you get 14 elements within that section. So we will talk a little bit more next week about electron configuration and how all of these orbitals play into the periodic table, and eventually how they play into periodic trends as well. So hopefully this will work and we will all be good to go. If you have any questions, remember I will be in class tomorrow at 12:30. So I will be able to answer any questions you may have regarding this material. I know it's a little bit confusing. Hopefully we will all be on the same page soon.